Hello students, in this video we'll discuss inverses of holomorphic functions under the right conditions which ensure that a holomorphic function is invertible. So let's suppose, and here's our first proposition, suppose that F's of domain omega into C is holomorphic, and one-to-one, i.e. injective, right? You're an injective function. Then F prime of Z is not equal to 0 for Z in omega. So when you're injective, the derivative can't be 0 at any point in the region, okay? Let's prove that, okay? Here's the proof of this proposition. Proof. Suppose that there is Z0 in omega such that F prime of Z0 is equal to 0, like that, okay? And then define a function g of Z, which is F of Z minus F of Z0, right? So clearly, g of Z0 is equal to 0, and g prime of Z0 is equal to 0. And this implies that g of Z0 is equal to 0, and g prime of Z0 is equal to 0. So there's a double root. So g has a double root at Z0. At least a double root, right? So not just a double root, but it could be deeper, right? Could be a triple root, but at least 2, right? Good. All right, so now, since it's an isolated 0, since this is isolated, if it was not an isolated 0, that would say that F is identically equal to F of Z0, not injective. So since Z0 is isolated, there is an R in delta. There are R greater than 0 and delta greater than 0, such that F prime doesn't vanish, g prime of Z, which is F prime of Z, is not equal to 0 on the disk centered at Z0 of radius R, closure minus, of course, Z0 itself, right? Because then you will be 0 there, okay? And moreover, F of Z minus F of Z0, it can't be 0 on the boundary, so it's bigger than some number by the minimum principle, right? On Z minus Z0 equals R. And that follows from the minimum principle. Okay, good. Okie doke. So now what? So now I'm going to pick W. Let W be a point in the disk centered at F of Z0 of radius delta, okay? In other words, what this says that W is sufficiently close to F of Z0, right? Okay, and this implies that, of course, that W minus F of Z0 is less than delta. Good. And then let H be F of Z minus W. Good. For modulus of Z minus Z0 equals R. In other words, if Z is on a circle centered at Z0 of radius R, then mod G of Z minus H of Z is going to be what? Is equal to? Well, G is going to be F of Z minus F of Z0. Then I'm going to subtract off what? I'm going to subtract off H, which is going to be F of Z minus W. So this becomes just W minus F of Z0, which we know by assumption is less than delta. But the delta is bigger than what? On this circle over here, delta is bigger than, or less than rather, mod F of Z minus F of Z0, like that. Great. And that's equal to G. So our conclusion is that F I'm sorry, that G and H have the same number of zeros, right? So H of Z has at least 2 zeros in this set over here, D, Z, 0, R, like that, okay? And they have to be simple. They are simple since H prime of Z is not equal to 0, right? What's H prime? H prime is just F prime, right? We're assuming that F prime is not what? Is not 0 in that disk minus Z0, right? And I know that we're not hitting Z0 because we're at W, right? Good. And so what? And so that implies that there exists at least a Z1 and a Z2 such that H of Z1 is equal to 0 is equal to H of Z2. What is that force? That forces, and Z1 and Z2 are not equal to each other, right? But that forces what? Well, that forces F of Z1 minus W to be F of Z2 minus W, right? Good. And so what this does is this automatically forces F of Z1 to be F of Z2, and that's a contradiction. Excellent, okay? Now, the nice thing is that we're actually able to get a formula for the inverse function. And how do we do that? We'll see in further videos how we exactly get this formula, but the formula comes down as follows, right? So if F is 1 to 1, corollary of this is that if F is 1 to 1, then F inverse of W in the right context is 1 over 2 pi I, the integral over C of some circle of just what? Of just Z, and then F prime of Z over F of Z minus W dZ. That, of course, just follows from the argument principle, right? So the argument principle guarantees that this is the formula for the inverse, but we'll really spell this out in further videos and see how this formula for the inverse helps us understand when F is a biholomorphism or not. Thank you very much.